Hello, this is Dr. Ayanshola Ogundele, Astronautics for Exploit. Space-based solar power system, the next frontier of renewable energy. The focus points of my presentation are as follows. Space-based solar power concept, advantages of space-based solar power system, technological feasibility of space-based solar power system, and orbital location of space-based solar power system. Over the years, via science fiction stories, novels, proposals, and showcasing of future solar power satellites by companies, several illustrations of the transmission of solar powers through space-based systems had been demonstrated and are still being demonstrated. In 1941, Isaac Asimov published a science fiction short story titled Reason in the April issue of Astounding Science Fiction. In his story, he narrated how a space station transmitted solar power via microwave beams to the planets and how robots with highly developed reasoning ability controlled the energy beams. Space-based solar power, the collection of solar power in the outer space via solar power satellites and transmitting it to the Earth has been said to be the renewable energy's next frontier. The concept of space-based solar power involves the use of spacecraft orbiting the Earth to collect solar energy, transmission of the energy to the Earth via microwaves, collection of the transmitted energy on the Earth by photovoltaic cells or antennas, and conversion of the energy into electricity suitable for residential and industrial use. For the collection of solar power, some of the advantages space-based solar power concept has over the Earth's surface are reduction of interference of wildlife and plants, easy redirection of solar power to the desired areas, ability of collecting surface to receive much more intense sunlight due to the lack of obstructions by the clouds, atmospheric gases, and a host of others. Presently, space agencies and space companies are investing in technologies that will fast-track the design, launching, and deployment of space-based solar power satellites. They foresee that space-based solar power systems will help in reducing global energy costs and greenhouse gas emissions. Various studies are being carried out for the assessment of the costs and benefits associated with the development of the space-based solar power systems. It is believed that these studies will provide useful information about the technical directions and help policymakers to make informed decisions. Space-based solar power concept. The concept of collecting solar power in outer space by solar power satellites and distributing it to Earth was first conceptualized in 1968 by Dr. Peter Glaser. High investments by the government and private companies and recent technological advancements are the driving forces behind the concept of space-based solar power. NASA Integrated Symmetrical Concentrator Space-based Power System concept is shown in this picture. The space-based solar power system involves the use of solar power spacecraft, a spacecraft equipped with solar panels. The solar panels on solar power spacecraft generate electricity, which is then wirelessly transmitted to the Earth through high-frequency radio waves. A ground antenna, called a rectenna, is used to convert the radio waves into electricity, which is then delivered to the power grid. The proposed Space Solar Array Alpha image and concept is shown in this picture. Energy conversion. Space-based solar power systems convert sunlight to some other form of energy, such as microwaves, which can be transmitted through the atmosphere to receivers on the Earth's surface. Solar power provides large-scale solutions to anthropogenic climate change or fossil fuel depletion, such as peak oil. The picture here shows artist's concept of a solar disk on top of a low Earth orbit through geostationary Earth orbit electrically powered space dock. Viability of space-based solar power. A study to re-examine the viability of space-based solar power, a long-touted solution to providing power from space, is being carried out by NASA. The push for clean energy. The new interest is generated in space-based solar power as a result of technological advancement and pushes for clean energy. The picture here shows a solar power satellite built from a mined asteroid. The new study to re-examine the past concept for collecting solar energy in space and transmitting it to the ground for conversion to electricity is being carried out. The aim of the new study is to compare the updated space-based solar power systems to terrestrial power systems and assess policy and implementation challenges they might face. The picture here shows an array of solar collectors that convert power into microwave beams directed towards the Earth. There are various advantages of space-based solar power system, and some of them are as follows. 24 hours illumination. A space-based solar power station in orbit is illuminated by the sun 24 hours a day and could therefore generate electricity continuously. This represents an advantage over terrestrial solar power systems, that is, the systems on Earth, which can produce electricity only during the day and depend on the weather. Arctic's concept of a solar power satellite to be located in a geosynchronous orbit of the Earth 35,786 kilometers above the Earth's surface is shown in this picture. The assembly of a microwave transmission antenna is also shown in the picture. Another advantage of space-based solar power system is that it's always solar noon in space and full sun. Solar noon, also known as the local apparent solar noon, and sun transit time is the moment when the sun contacts the observer's meridian, which is the culmination of meridian transit, reaching its highest position above the horizon on that day and casting the shortest shadow. The picture here shows space-based solar power system. Another advantage of space-based solar power is the lack of obstructions. Collecting surfaces could receive much more intense sunlight, and this is as a result of lack of obstructions. For example, atmospheric gases, clouds, dust, and other weather events. Consequently, the intensity in orbit is approximately 144% of the maximum attainable intensity on Earth's surface. The picture here shows artist's concept of the Japanese Yuko spacecraft, a solo observatory spacecraft of the Institute of Space and Astronautical Science. Another advantage of space-based solar power system is better power collection. A satellite could be illuminated over 99% of the time and be in Earth's shadow a maximum of only 72 minutes per night at the spring and fall equinoxes at local midnight. Orbiting satellites can be exposed to a consistently high degree of solar radiation, generally for 24 hours per day, whereas Earth-service solar panels currently collect power for an average of 29% of the day. The picture here shows solar collecting satellite. Another advantage of space-based solar power system is easy power redirection. Power could be relatively quickly redirected to areas that need the power most. A collecting satellite could possibly direct power on demand to different service locations based on geographical baseload or peak load power needs. Interference reduction is another advantage of space-based solar power system. Space-based solar power reduces plant and wildlife interference. The picture here shows illustration of solar farms in space. Technological feasibility of space-based solar power system. Over the years, various studies carried out on the feasibility of space-based solar power system confirmed that it is very feasible to design and launch space-based solar power system. Despite space-based solar power system confirmed feasibility, the space solar power system technologies are still in their very early stages of development. The high upfront cost for the implementation are one of the limiting factors. The picture here shows demonstration of space-based solar power. Space-based solar power system building blocks. Many of the building blocks for space-based solar power systems are based on existing or emerging technologies for space and on-ground applications. Some significant developments are still needed to enable the development. The development and construction of large modular structures in space is a major challenge. Solar Power Plant Space Station is shown in this picture. Space-based solar power system launching. Low-cost, heavy-lift launchers are needed to enable launching of space-based solar power. A reduction of launch cost will help to deliver into space the infrastructure necessary for a fully operational space-based solar power system. The picture here shows operation of space-based solar power system. Orbital location of space-based solar power system. Different locations have been proposed for the siting of space-based solar power system. There is a proposition to locate space-based solar power system in the geostationary orbit. The main advantage of locating a space power station in geostationary orbit is that the antenna geometry stays constant, and so keeping the antennas lined up is simpler. The picture here shows space-based solar power satellite, a satellite that captures light from the sun and being powered back to the Earth. Continuous power transmission. At geostationary orbit, nearly continuous power transmission is immediately available as soon as the space power station is placed in orbit. Low Earth orbit requires several satellites before they can produce nearly continuous power. A collection of low Earth orbit space power stations has been proposed as a precursor to geostationary orbit, space-based solar power. The picture here shows solar power plant in space. For more information, contact Astronautics for Exploit. You've been watching and listening to the presentation by Dr. Ayenshola Ogundele, Astronautics for Exploit, with the topic Space-Based Solar Power System, the Next Frontier of Renewable Energy. The focus points of the presentation are space-based solar power concept, advantages of space-based solar power system, technological feasibility of space-based solar power system, and orbital location of space-based solar power system. Thank you.